Hello everyone and welcome to Practical Mechanics. I'm Mohsen. This video is about geometric tolerance, perpendicularity that apply to a feature and feature of size. Let's consider first perpendicularity that apply to a feature, which is a planar surface. There is an object and we consider the front view. And the bottom surface is taken as datum A, and this surface must be in production perpendicular exactly 90 degrees with respect to the bottom surface. Then we can apply feature contour plane that has information about the symbol of the geometric tolerance, the value of the geometric tolerance, and datum. We can apply it in two ways. Extend the surface and apply it like a flag. Perpendicularity tolerance pointed to with respect to datum A. Or draw feature contour frames separately with respect to datum A and apply it with a lead. Yeah. It depends on the space that you got in your monitor, on your paper, which method you use to apply the tolerance. In real life production, it's not possible to make angle exactly 90 degrees because of error in production. Then designer considers some allowance for this angle, 90 degrees angle. And according to geometric dimensioning and tolerancing ASME ASME Y14.5, it means that this surface must lie inside a zone. And that zone must be perpendicular to the datum, not the surface. Zone is two parallel planes, and the distance between these two parallel planes is equal to the tolerance value, 0.2. As long as the real surface is between two perfect parallel planes that are perpendicular to datum A, these two parallel planes are perpendicular to datum A, then the part will be accepted. An angularity 90 degrees angle between these two will be accepted. That's the interpretation for perpendicularity that apply to a feature. When perpendicularity applied to a feature, we do not use any modifier except T modifier. T modifier, which is called tangent plane, if it comes in front of the geometric tolerance, means for verification of this perpendicularity, we have to use a tangent plane and put it on the surface and then moving the dial indicator above that surface, because the surface has irregularity and doesn't allow easy movement of the dial indicator. In this case, assume that we have a irregular surface like that, and we take this part as datum A, and we wanted to check the perpendicularity, we just put the tangent plane on the top of the plane that only contact with the highest point of the surface. That's the tangent plane. Only contact with the highest point of the surface. Let I make it a little triangle color. This tangent plane must lie between two parallel planes, which is the zone. Consider the zone, and that zone must be perpendicular to datum A. Then, when perpendicularity applied to a feature, it limits flatness as well, flatness of the surface. We define flatness, and we have a video about the flatness, which is the distance between the highest point and lowest point of a surface. And we wanted to limit this distance or reduce it with using the flatness geometric tolerance. Perpendicularity also can limit the flatness as well. But if you use T modifier for the surface, it means that I can show this surface like this. Perpendicularity applying here. Point 2, T modifier, respect to datum A, and you can choose this right side or left side surface as datum A. In this case that you use perpendicularity, and sorry, I show it in a if the perpendicularity applied to the top plate datum A with respect to A, left side as datum. In this case, you have to use tangent plane. When you use tangent plane, some points of the surface, lower point, will be outside of the tangent plane. Tangent plane only contact with the highest point. And it means that when perpendicularity tolerance is with T modifier, it cannot limit flatness anymore. Okay? Then here, without T modifier, it can limit flatness, but if we use T modifier, it cannot limit flatness because some points of the surface is out of the zone and is not inside the zone. Here, all points, top and bottom points, or highest and lowest point, all of them are inside the zone. Here, the only condition is that the tangent plane must be inside the zone, not the whole surface. Okay, that's a condition. This is why you cannot limit flatness as well. Then, this is the perpendicularity applied to a feature. Thanks you for your watching. See you in the next video.